Today we're going to look at a process called completing the square, which enables us to write quadratic expressions in the form x plus a all squared plus b, where a and b are just constants. Let's start by seeing how certain expressions factorise. If we've got x squared plus 8x plus 16, this would factorise to x plus 4, x plus 4, which we could write as x plus 4 all squared. Let's have a look at another one. X squared minus 2x plus 1 would factorise to x minus 1 all squared. And a third one, x squared plus 6x plus 9 would factorise to x plus 3 all squared. These quadratic expressions are called perfect squares because they factorise into a double bracket that is squared. X plus 3 times x plus 3 is x plus 3 squared. You might notice that when we look at these expressions and their factorised form, that if we look at the number in the bracket, so here we have a 3, the x term is double the 3 and the term at the end is the 3 squared. The same applies for this one. The x term is double minus 1 and the term at the end is 1 squared. So we can use this idea to complete the square on quadratic expressions that aren't perfect squares. So if we know that x squared plus 6x plus 9 factorises to x plus 3 all squared, let's just say we had the quadratic expression x squared plus 6x without the plus 9 on the end. Well, this is equivalent to x squared plus 6x plus 9 take away 9, because the plus 9 and the minus 9 cancel out. We know from above that the x squared plus 6x plus 9 is the same as the x plus 3 all squared, so we can use that so the pink parts are equivalent and then we subtract the 9. So x plus 3 all squared minus 9 is equivalent to x squared plus 6. It's the completed the square form, where we would say that a is equal to 3 and b is equal to minus 9. If we have a look now and we started perhaps with, instead of just x squared plus 6x, we've got x squared plus 6x plus 5. Again, we know that the first part of this quadratic expression, the x squared plus 6x, is the same as x plus 3 all squared, and then we need that minus 9 on the end in order to cancel out the plus 9 that we would get when we expand that double bracket. But now we have a plus 5 on the end, so we need to pop that plus 5 back on the end and then we can simplify. So we end up with x plus 3 all squared, then I've got minus 9 plus 5, which gives me minus 4. So this is completed the square form where a equals 3 and b equals minus 4. In order to help us to remember what we do with this process, I have a little saying which is called halve it, square it, subtract it. So let's see how we'd apply that little saying to this example back down here. Halve it comes from we halve the coefficient of the x term, so we halve 6 and that's what goes in our brackets here, it's the plus 3. Square it means we square this 3, which gives us 9, subtract it gives me my minus 9 on the end, and then I just need to add my plus 5 back on and then simplify. Right, let's go through another one of these and you can write it down in your notebooks. So if I'm asked to write the expression x squared plus 4x plus 3 in the form x plus a all squared plus b, I'm going to go through my halve it, square it, compare it. So I'm just starting off by looking at the first two terms, x squared plus 4. So I write down my x inside my bracket with my squared, and I think halve it. So I halve plus 4, which gives me my plus 2. Now I'm doing square it. So I square the 2, which gives me 4, and then I subtract it. So what's in pink here is equivalent to the pink above, the x squared plus 4. Then, because I've got plus 3 on the end, I pop the plus 3 on the end, and then I put that equal to, simplified version, x plus 2 all squared minus 4 plus 3 minus 1. So a equals 2 and b equals minus 1. Right, we're going to do one more of these, which you can write down, and then I'm going to get you to have a go at a few questions before I show you something else. So let's try this one. X squared minus 6x plus 7 in the form x plus a all squared plus b. So we're starting off, find the equivalent to x squared minus 6x. So I start off by setting up my bracket with the squared. I think halve it. Half of minus 6 is minus 3. I need to pay attention to this minus sign and include it here. Square it. 3 squared is 9. So I subtract the 9. And then I look at what I had on the end, plus 7. And I add it here. And then I simplify. X minus 3 all squared minus 9 plus 7 is minus 2. So a equals minus 3 and b equals minus 2. I'd now like you to pause the video and have a go at exercise 10H, which you will find in the files folder on Teams, and I want you to have a go at question 2 only for probably 5 minutes, maybe a bit longer, just to have a go at a few of those so you can get a bit more confidence. Don't forget to check your answers. The answers for the textbook are also in files. I think I put them under class materials. Now we're going to have a look at how we can use completing the square to solve quadratic equations. So we already have two ways of solving quadratic equations. We can make sure that the quadratic expression equals 0 and factorise, or we can use the quadratic formula. So this is giving us a third way to solve quadratic equations. We always have to make sure, as with all quadratic equations, that our quadratic expression equals 0 first. So if we look at this question here, which you can write down in your notebooks either as we go along or afterwards. The first part of the question asks us to complete the square on the quadratic expression x squared plus 6x plus 1. So let's do that first. Again, I'm going to use my colours. So my pink part, the x squared plus 6x, I can set up my bracket. I can halve my plus 6 to give me plus 3, square my 3, which gives me 9, and subtract it. Then I need to add my 1 on the end. Let's simplify. X plus 3 all squared minus 8. It then says hence solve x squared plus 6x plus 1. So the hence means use what you've done in the first part of the question. So if we know that x squared plus 6x plus 1 is our equation to solve, x squared plus 6x plus 1 is the same as x plus 3 all squared minus 8. What we can do now, instead of expanding the bracket and going back to this form and using the quadratic formula, we can solve from this line here. So all we need to do here is first of all add 8 to both sides, giving me x plus 3 squared equals 8. Then we can square root both sides, but what we need to remember here is we need the positive and the negative square root, so I get plus or minus 8. This is what's going to give us the two solutions that we know we should always get for a quadratic equation. We should simplify that third. Root 8 is the same as 2 root 2. And finally, we're going to take 3 from each side, and we normally pop it at the front, so I've got minus 3 plus or minus 2 root 2, which gives me two solutions to the quadratic equation, x squared plus 6x plus 1. Right, I'd like you now to pause the video and I would like you to have a go back to exercise 10H, and I now want you to try some questions, parts from question 3 and question 4. Again, check your answers and mark as you go along. I'd like you to spend about 10 minutes on these, and then I want you to come back to the video because we're going to look at one other thing. Right, so hopefully now you've had a go at some parts from question 2, question 3 and question 4. And to finish off this lesson, we're going to look at something called equating coefficients. So you can write this as a subtitle in your notes books. So sometimes when we're using the completed the square form, we have unknowns on both sides. So for example, if I'm given that x squared plus px plus 12, where p is a coefficient that we don't know, is equal to x plus 3 squared plus q, I could be asked to use equating coefficients to find the values of p and q. So what we're going to do here is we're not going to do anything to the left hand side. So I'm just going to rewrite that out, and then I'm going to expand the right hand side. So this is going to give me x squared plus 6x plus 9 plus my q on the end. Now by equating coefficients, that means equate what's in front of each of the different terms. So with the x squared term, they don't have a coefficient, but as expected I've just got 1x squared on the left and 1x squared on the right. With the x terms, the coefficient on the left is p and the coefficient on the right is 6. So that means I know that p must equal 6. With the number part of the quadratic expression, on the left I've got plus 12, and on the right I've got 9 plus q. So that means 12 must equal 9 plus q, which means q equals 3. And there I've used equating coefficients to find the values of p and of q. What I would like you to do now is I would like you to have a go at finding the unknowns by equating coefficients on a file that is uploaded onto the files section for this lesson in Teams. Good luck. I'll be online on Teams while you're doing this lesson, so if you're unsure of anything you can ask me in posts, or if you would like to speak to me then you can request a meeting.